let's review. Okay, so these basically are quiz questions that were just kind of modified a little bit. So there was a little bit of confusion about population and sample data. So remember, sample is subset, as in not everybody. Population means everybody. So a historian summarizes the ages for all deceased past presidents. Is that everybody or just some of them?
All deceased past presidents.
All deceased past presidents. All. So all means all, yes. All means all. No, I think all suggests this is a population. We're looking at the entire collection of deceased past presidents. Okay, a nutritionist wants to determine which of the two weight loss programs is more effective. He assigns 25 volunteers to each program and records participants' weight loss after 2 months. That's a sample because they're trying to look at efficacy of two programs for everybody based on like a small group of people. That's a sample. Oh, sample, small. Alliteration's a good tool. Okay. For the following variables, indicate whether the variable is categorical or quantitative. So category means categories, quantitative means like a number, basically. So length of forearm from elbow to wrist. Quantitative. This wasn't required, but if I say and continuous, does that kind of make sense? Yeah. Continuous meaning any values possible. Your form could be 2.75386427. Well, the 2 is kind of short. 10.765432189237 2 inches long.
That's really accurate.
Yeah, and that's the point, is like if you went to lots of degrees of accuracy, you could get any possible value. Favorite color for an automobile? Categorical. It's okay. It happens to all of us. We're in math class, so English unit is less important. Although there's a lot of reading in this class, though, so English unit is kind of important. Boo. With categorical, there were variables that were categorical, and they were called ordinal, which meant there was like a natural order to things. Would car color have an order? No. So this is not ordinal.
Would it be ordinal if it was specifically shades of white to black?
Yeah, like if it was shades of gray. Maybe then you could
try to avoid that.
I know, try to avoid that one. Okay, but yeah, maybe then you could assign a color if you had some kind of order in your colors. But color, generally speaking, no. The quantitative, good examples of ordinal variables are things like your rating of how, worthwhile was this class to you. Worthwhile, meh, like in the middle. Meh to, yeah, stuff like that. Like things on surveys and stuff. Okay. For each of the following situations, specify which is the explanatory and which is the response variable. For college students, is there a relationship between grade point average and average number of hours spent studying? So, so explanatory number of hours studying. And the response is their GPA. Okay. So just testing some vocabulary. All right. I think I asked for this question a little bit different way on the quiz, but I think I might have said find a 5-number summary. So first of all, we have a set of exam scores, and this is an exam that's obviously not out of 100, right? Probably out of 150. First, find the median. So if you're going to find the median, what do you have to do with the order of the numbers in your list? Put them in order, yeah. So who's smallest? 102, 110, 122, okay. And then the curve killer. Did I miss somebody? Oh, I just put them backwards. Yeah, 127 should go before 132. Yes, thank you. One thing you can do to check and see if you have the numbers, just count them, right? I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. That's how I check if I got them all when I reorder them in my list. Okay, so is there a specific middle value for this list? No, you have to take the average of. So the median is equal to 122 plus 123 out of over 2, or 122.5. Okay, I'm going to do part B on the same slide. So part B says to find the values of the upper and lower quartiles. So with this, you just do the median process again, okay? Now, when you have, at least your book's way of specifying this, which is not perfectly consistent, you use these two values to find the median. You're going to use them again when you find the medians of the lower and upper. So the upper is called Q3, the lower is called Q1. And to find those, you just do medians of both lists. Let's ask your question after I finish, okay? Because I think I know what it is. So first of all, for the upper quartile, what's the median of this upper list? 127 plus 132 over 2, which is that's quartile 3, or the upper quartile. Quartile 1 is 110 and 118 out of 2, which is 114. Okay, now what if, just hypothetically, what if I'd had another number in there? What if I'd had another 122, okay? Is that what your question was going to be? Yeah, I thought. And in that case, if your median was an actual number, then you don't use it for either side. Does that make sense? Okay, so in this example, we use these two to find the median, but we also use them in the quartile finding process, right? If instead I'd had 9 test scores, and my median was 122, when I go to find the quartiles, I don't use that value, because I don't know where to put it.
So the same way we just did it.
Exactly, you just disregard the one that is the middle. That answers your question, right? I'm pretty sure the quiz question that you had was like this, where it had 8 values. Yeah. Okay. Alrighty. So upper, lower we got. Find the interquartile range. So how do you find the IQR?
Q3 minus Q1.
Great, Q3 minus Q1. It's how far it is between the upper and lower quarters, right? So Q3 was 129.5. And Q1 was, so that's, okay. And what that IQR is used for is to identify what kinds of things? Yes.
Well, I had a different question.
Okay, what is it?
On the test, if we don't show the work,
Oh, you can just tell me what your IQR is. That's totally fine. Yeah, I'm showing more work here than you would definitely have to in your test because it's a super easy calculation. No problem. Okay, so part D says to find any outliers. Okay, so to find outliers, you look at what times IQR? 1.5, yep. So 15.5 times 1.5 gives you 23.25. Okay, so you're too low if you are below Q1 minus this 1.5 IQR that we just found. So if you're too far below quartile 1, so that's 114 minus 23.5, or 0.25, sorry. That gives, do you guys get 90.75? So is there any test score that's an outlier on the low end?
No.
No, okay. You're too high if you're above what plus 1.5 IQR, which Q3, great. So that's 129.5, I did it wrong in my notes, plus 23.25. What's that give?
150
So are there any outliers?
Yeah.
No. On your test, you're gonna have to show me a little bit of work. You've gotta show me the too low number and the too high number. Does that make sense? So I can gauge that you actually know how to find those numbers correctly and just get lucky and say yes, no, and lucky guess? Okay? I think I said to support your answer with numbers, meaning like give me some work. Okay. Find the mean and standard deviation for this data set. So when I wrote this quiz last semester, I actually gave them the formula. I'm not gonna do that on the test, so just make sure that you have that written down or know how to use this formula. Okay, so first thing, find the mean. So how many things are in my sample? 4, okay. So x bar, which is the mean, is 22 plus 27 plus 30 plus 21, all divided by 4. Do that, it should come out to be a whole number. Did you guys get 25? Or are you still punching away? Is it okay with that? Count the tens. 2, 4, 7, 8, 9. Yeah, okay. Yeah, all right, great. Now, I think the way to find the standard deviation is actually first to find the variance, which is s squared, and then square root at the end. And the way you do this is, you remember that this x sub I means observation, minus x bar means the mean you just found, right? And find all those differences and square them. So what's our first observation?
22 minus 25 squared.
Plus,
27 minus 25 squared.
yep, plus,
30 minus 25 squared. Plus 21 minus 20 squared.
I just boo-booed, plus 21 minus 25 squared, yep. And all that is divided by,
Or 3.
n minus 1. And the reason why it's number minus 1 is a complicated one that I'll admit that I don't actually even know yet. So like I'll learn it in a theory class. And this isn't like, I mean, you can do these things with a calculator, but they're actually not that hard, so let's just do them by hand. What's 22 minus 25? Square that, it makes 9. 27 minus 25 is 2. Square it, you get 4. Plus, I think 25, do you agree with that? And then plus 16? All divided by 3? This ends up giving you s squared equals 18. So that officially is called the variance. And to find the standard deviation, what do? How do you get the s by itself? Square root it, yep. And then give me a decimal, should be approximately 4.24. You buy that? 18 is kind of close to 16, right? So root 18 is kind of close to 16's root.
So do you want 2 decimal places on that?
I specified on the test, I was pretty careful, and I'm pretty sure I said 3. I'm pretty sure that's what I said, but I'm not 100% certain. That's 2, but I mean, you know, just read the directions. Okay. Another thing we have in this first unit was talking about the, what's called the 68, 95, and 9.7 rule. And so 68% of people fall within how many standard deviations? 1. Yep. So x bar plus or minus 1 standard deviation. So if your mean is 540, what's the low end of 68%? 490. And what's the high end? 590. So given this sort of bell-shaped curve, which is so hard to draw, 68% of people fall in the middle, plus or minus 1 standard deviation from the mean. 95% of people fall between, yep, x bar plus or minus 2 s's. So twice the standard deviation is 100, so the low end is 440, the high end is 640. And almost everybody falls within plus or minus 3 standard deviations, which is 390 and 690. So really, once you end up being more than 2 standard deviations away, you're a little bit special, aren't you? That's an S, yeah.
Okay.
S for standard deviation. Does that make sense?
Well, I was just asking if the 540 was the representative S and the 50 was X.
The 540 is the mean, and the 50 is the S.
So that would be X bar.
Is that all right?
I got confused when we did this.
Yeah. Okay. Ready for the next one? A little bit different, but it's related. So the head circumference of adult males has a bell-shaped distribution with mean equals 56 centimeters. That's X bar is equal to 56. And standard deviation 2, so S equals 2. I should just write them down anyway, so it's good. What is the head circumference such that only 2.5% of adult males have a smaller head circumference? And how about a larger head circumference? And then what is the head circumference such that only 16% of adult males have a larger head circumference? There's 3 questions in there, aren't there? Okay. So the picture you should have in your head is this. You've got this bell-shaped curve. The X bar is equal to 56. So what does 68% of people fall between? 54 and 58, right? Okay, how about 95% of people?
52.
Okay, so there's the 95%. Okay. So what is the head circumference such that only 2.5% of adult males have a smaller head for circumference? So looking at that red part, you've got this bit and this bit. So does it make sense that those 2 things called tails total to 5% when you count both of them? So there's 2.5% that are above 60, and there's 2.5% that are below 52, right? So head circumference so that only 2.5% have smaller. So only 2.5% smaller with circumference equal what? 52 centimeters. So if you're at 52, if this is your head measurement, you're right here, right? 2.5% below you. Okay. How about the only 2.5% bigger? And then the last one is only 16% bigger. That's at 58. And the reason is that 68% fall within the blue lines, leaving 32 left over, right? The half 16s below, half 16s above. I think the question that maybe you were going to ask was that, are we ever going to get a number that isn't 2.5 or 16? No, okay, that's not the question. But the answer for that question is that you won't, because you're using a special rule and they have very special numbers for that, okay? What was your question?
I was just gonna say, if we explained that it would be like 2 standard deviations, do we have to draw that pretty graph, or can we just?
No, you can just explain it in words too, but I like the visual personally,
No,
but
sure,
yes.
yeah.
Would what you wrote be enough as far as explaining it in words?
Yeah, I think that explaining it with a picture is totally fine. Did I say explain? No, I'm just gonna look for your number here. I'm gonna assume if you get the number, you got the picture down. It's easier for you to grade that way, not to read. Okay, ask carefully.
No, I'd probably give it a little more, like 2 standard deviations is 2.5 or something.
Yeah,
I was just saying,
that's
we have to
totally
draw
fine.
That, my art's terrible.
Yeah. I won't ever grade your art though.
Okay, well.
Yeah, but I totally get it. You can summarize it in words. Okay, last thing from this first unit. Remember this Z-score formula? That was actual minus mean over standard deviation. And this will tell you how many standard deviations above or below the mean you are and kind of tell you how unusual you are. So you have the mean weight for men 18 to 24 is 170, and the standard deviation is 20. Find the standard Z-score for the following weights. So it would be 110 minus 170 over, so Z is, I think it's -3.
Yeah.
Yeah, sorry.
That's okay.
Oh, I forgot the parentheses.
Yeah, good illustrator.
Make sure you put the parentheses.
Yeah, make sure you put parentheses, because if you don't, what your calculator is going to do is it's going to do 170 divided by 2, 20,
Yep.
and then it's going to do 110 minus that.
Yep.
Does that make sense? Okay. Now, tell me, I don't know if this is on your notes at all, but is this person unusually light, unusually heavy, and how can you tell?
It's like,
Unusually light. So the light part comes from the fact that it's negative. He's below average, right? How do you know he's unusually light? He's 3 standard deviations away, okay? Or 3 standard deviations below the mean. Pretty much once you get more than 2 standard deviations above or below the mean, you're kind of special. You're in the bottom 2.5%. Or in this case, this person's in the bottom 0.015%, right? Because 3 standard deviations is 99.7, meaning there's 0.3% in both ends, right? This one's in the bottom. It's super, super teeny person, right? This person, 300 pounds. So that will be 300 minus 170 over 20.
6.5.
You got 6.5. Well, that is probably usually light and usually heavy. I would say very unusually heavy. I guess I didn't make that an option. If you get a Z-score of 1, are you very special? No, you're kind of like average-ish. Z-score of 0.5, you're even more average-ish. You're not special, you're just average, sorry.
Isn't it
Sorry, guys.
If it's average, it doesn't like between -1 and 1.
Yeah, let's just say if it goes below 2, does that make sense? Then you're really strange.
Yeah.
But once you're in the middle, 68%, that's kind of like, your average-ish height. You could say slightly below, slightly above, in the negativity, positivity. Okay, so here we go. Chapter 3, Quantitative Variables. So tell me, is there likely to be a positive association, a negative association, or, oh, I can do whiteout, no association. There you go, look at that. It's not, there's no T there ever. Briefly explain your reasoning. So a lot of you on this question, I think it was a homework question, like, oh, forearm length and foot length are approximately the same. So if you were to do a scatter plot of people's, so we're going to do forearm and foot length. Okay, so mine is here. My husband's, who is 6 feet tall, is probably above or below mine. Like to the right and above, right? He probably has both a little bigger, longer forearm and a bigger foot, right? Do you agree with that? Mm-hmm. If somebody is shorter than me, like they're like 5 feet tall, probably smaller feet, smaller forearms, right? So it's probably going to look something like this. But it kind of goes up. As forearms get longer, feet get longer, right? So that's a positive association. And what we can say is as forearm length goes up, do you agree with that relationship? If somebody has a bigger, longer forearm, they probably also have bigger feet. Yes? Okay. Than somebody who does not have smaller forearms and smaller feet. Okay, as long as you don't overtrain and run too much and injure yourself, assuming those things. If you run more, what's going to happen to your marathon time? Yeah, you've got those like crazy people who run like 100 miles per week and their times are down here. You got me running like 30 miles per week and my time's up there. So yeah, this is a negative association. as miles run goes up. Marathon time goes down. Okay. Alrighty. They'll definitely like this in the test. So regression equation for stopping distance and speed is given by this. Find the slope and interpret it in terms of how average stopping distance changes as the speed increases for a car. So one thing that I might not do in your test is I might give it to you like this. I might say y hat equals negative 44.2 plus 5.7x, but this is the way your book gave it. They somehow don't seem to think you guys can handle y's and x's. I don't know why, because you totally can. They are insulting your intelligence. Be angry. All right, find the slope and tell me what it means. So first of all, what is it?
Negative 44.2.
Ooh, no,
5.7.
5.7.
Yeah, right on.
Well, if you give me a factor of interpretation after you find the slope, I'm still going to give you most of the points, actually. Because the hardest thing is, like, you know, what the interpretation is.
The thing is like the line equation is mx plus b, but they always reverse it to where it's b.
Yeah.
Yeah, and that's a really common thing in stats. They even often call it b0 plus b1x. They don't even use m and b.
Let's not do that.
No, but the reason they do that is because then you do things that have like x squareds or other terms, and they call it b0, b1, b2. I mean, so it really isn't different. I mean, this is like the b from a regular equation, and b1 is like their m. M is with the x. You guys passed Algebra 1 ages ago, so you can totally figure this out. Allegedly tested in this class. Allegedly you passed Algebra 1.
Some of us-
Some of Algebra 2. Which just means you have the content knowledge of Algebra 1. Hopefully.
Really good at tests.
Or that. Okay. So what's y talking about? Change in stopping distance, so that's stopping distance in feet. And x is
Our speeds.
speed in miles per hour, yep. And so you really have 5.7 over 1. I think it's easiest to begin with the denominator. So if mph goes up by 1, what happens to stopping distance? Stopping distance increases or decreases? I think it increases. Because it's positive 5.7? And this should make sense in life, too. If you go faster, it takes you longer to stop, yes?
Yes.
Yes, okay. That's why in cities the speed limit is 30, not 60. Because there's like stuff going on, right? You need to be able to stop. And there's my moral lesson of the day. Okay. What is the estimated average stopping distance when the speed is 80 miles per hour? This yawn? What? I'm just kidding. 5.7 times 80. Wait, 80 miles an hour. Yawn. It's outrageous. You shouldn't go that fast. So, what is that? I got 411.8. 5.7 times 80. Oh, you just didn't do the minus 44.2 yet.
Yeah. 411.8.
Okay, so on average, if you're going 80 miles per hour, it's going to take you that long to stop. Think about that next time you're pummeled on the park's highway, like, and there might be a moose in front of you. Just don't go so fast. Try to save your lives. Nope.
Sweep my leg.
Mythbusters did a thing on that, and it doesn't work.
Yeah, it like sucks them into the back window.
Yeah. So there was this theory that going faster, if you knew you were going to hit a moose, was like going to make it better. Because you think like the moose is just going to like go over you, and you know, the velocity such that it just goes over you. Mythbusters did a thing on this. They found somebody in Sweden who'd made a moose out of rubber. It was their thesis. And they took rubber moose and they hit it with cars and found that going faster made it worse. The moral of the story is you should always try to stop, probably,
So basically, don't pass over a moose or you'll total your car
and probably die.
and die.
Yeah. Okay. So, Mythbusters.
No, but like, you must have really incredible insurance. I was just thinking about like.
Yeah, later. Okay, that's yeah.
Anyway.
So stopping distance when driving 20 miles per hour is 50 feet. What is the prediction error, or in other words, a more common word is called the residual for this speed. So remember, residual is y minus y hat. So y is the thing that you observe. Y hat is the predicted thing you find from the regression line, predicted. So what is the observed stopping distance that you found? 50 feet, spectacular. What do you plug into your regression equation to get y hat?
20 miles per hour.
20, great. Negative 44.2 plus 5.7 times 20. So I got that y hat is 69.8. So y minus y hat is 50. Ugh. Minus 69.8. Mm-hmm. So is this car that we observed, is it better or worse than the average?
Worse.
It's better.
Well, it means better.
Oh, because.
Well, I guess I could have clarified that shorter stopping distance is better, right?
Yeah.
Better than average stopping distance. Or you could say the stopping distance is below the average, right? The negative tells you it's below the average by 19.8 feet. Okay. Would it be appropriate to use this regression line to estimate the stopping distance for a motorcycle? No. Heck no. And the reason being is that the data probably used were, I guess I didn't even say, but we're going to assume the data was from cars.
It's his car.
Oh, it does say car? Okay, great. I mean, and if they're talking about cars, things like SUVs and trucks also maybe would be different, right? They tend to be heavier, so maybe more stopping distance. Okay. The last thing, and this was the thing that was hardest for a lot of you, is interpreting the y-intercept. And what you have to know is that the y-intercept is what happens when x is 0. So y-intercept means x equals 0. If you're going to be on the y-axis, your x has to be 0. It's just the way it is. Look at a picture, blah. Y-axis there, over, nothing. Okay. So first of all, what is it?
Negative 44.2.
You could also call it b, but whatever. It's negative 44.2. So this is the stopping distance when going how fast?
0 miles per hour.
Can you have a negative stopping distance? No. You cannot have a negative stopping distance. Makes no sense. But what I'm going to be looking at when I grade questions like that is, can you find the y-intercept? And do you know it means that x is equal to 0? Does that make sense? Those are the things I'm looking for. And then tell me, it should be pretty obvious if it does or does not make sense. Oh, it's a negative number. Could, yeah, anyway. Oops, wrong thing. There we go. All right. So I have this regression equation. We're going to find the sum of squared errors. So when you find this sum of squared errors, SSE, is the sum of the residuals squared. And that's a criteria you use to find these regression lines in the first place and figure out which one is actually the best one. So first, find y hat for every single data point. So what is y hat of 1? 5. You get that by plugging 1 into this equation for x, right? Does that make sense? What is y hat of 2? Y hat of 3 is
17.
And y hat of 4 is 17. And for some stuff like that, it's easier not to use a calculator, isn't it? It's actually faster to use your brains than to punch those buttons. And then these values are all the original y's. So to find the sum of squared errors is you find the errors, which is how much the difference there is between the actual and the line, and square them. So the first one, what's the first y value when x is 1? 4 minus 5, and then squared. Plus,
5 minus 9.
squares. That one was really off, wasn't it? Plus, and then plus. So the line we picked wasn't so bad at the first point and the last point, but it kind of sucked in the middle, didn't it? Okay, so the first 4 minus 5 is -1. -1 squared is 1. 5 minus 9 is -4. Square that, you get 16. Yep. -3 squared is 9. And then 1. 27?
Yeah.
Okay. Okay, awesome. If r squared is 1, what are the possible values for r?
Negative.
R is equal to +1 or -1. So when you have a perfect correlation, so this is the correlation coefficient that tells you how strongly related two things are. Now, strongly related means falling close to a line. So if your R is perfectly +1, your points fall in a perfect straight line. Okay? If R is -1, they fall in a perfect straight negative slope line. If the more those points wiggle,
Further away.
the further, so that one versus like, do you see how the second one's like much more spread out than the first one? This means that this one's gonna be closer to 1 than that one. The closer they fall to a line, and the line has to have positive slope. No correlation looks something like flat slope, 0 slope. So hopefully that should help the next question make more sense, because it did give some of you problems on the quiz. So it's process of elimination, and there are some that are easy to guess. So they gave you some potential correlation coefficients, and I changed them slightly for your quiz, but kept them pretty similar. Match these to graphs. So the first one's -0.9. So the first thing, you're looking for one that's decreasing, right? And is quite close to a straight line, right? So that's graph 2. Most of you got that one right because you got that, oh, it's the only -1, right? But the reason it's also 0.9 is that those things are almost exactly in a straight line. Okay, now comparing graph 1 and graph 4. Both positive correlation, right? They're kind of going up, but which one's tighter together? That means it's the higher correlation. So that's 0.6. And then this next one, graph 4, is straight line, that's 0. The most common mix-up on this was the 0.6 and the 0.3. So the tighter they are together, the closer to 1.
I thought the bigger the number, the more drastic
Yeah, that's what I thought too. That's what I was
The bigger the number, the more
the drastic, the spread out the graph would be.
No, that was my fault. The closer it is to 1, the closer they fall to a line. 1 is perfect line, 0 is mishmash, -1 is perfect negative line. Okay. So chapter 3, that was all quantitative data. Chapter 4 was categorical stuff, right? Holy moly. So survey of internet users at my Pew Research Center. Ask whether they use social networking sites. Find the row percentages. So it's nice for me if you kind of keep this in a table. So men, women, yes, no, and we'll explain what they mean. So what percent of men said yes, they use social media?
63.05.
I got 62.1.
That's what I got.
Because you do 5, was this the row, out of 846.
Can you write that out?
Yep, I can. I just have to make my pencil smaller. Give me a sec. So 525 out of 846 is 62.1%. And for the no category, it's
37.9.
mm-hmm. And those should add up to 100, right? Roughly. But they do. So for the women, it's 679 out of 956. So let's just say 0.0% versus 277 out of 956 as well, right? So 29%. Okay. So these tell us the percent of men and percent of women who use social networking sites. You can tell that this book is a little bit outdated on this, right? I bet those.
How come you rounded up the 29? but
Because
not
it was-
27.9?
It was 28, it was 0.2897.
Oh, okay, I didn't hear that.
Yeah,
28 point something, was it?
yeah, it's 28.97.
Yeah, so you had to run it up to,
Up and then up.
up and then up again, exactly, yep. Does the explanation make sense? Tells us for your groups, of your men, this percent use social media, this percent didn't. Of your women, this percent did, this percent didn't. So this one lets you compare the sexes to each other. Does that make sense? So let me say, add that compares men to
277 divided
956. And that's what it came out to be before rounding. So it's got to go up and then up again.
by, so then we take that one by.
So what either of those answers were, compare and everyone.
That'd be fine too, I think, yeah. Okay. How about the columns? What's a little bit different here? Total is the bottom, yeah, so let's just put the table again. Men, women, yes, no. Okay, so the proportion of yeses who are men, that's 525 out of,
12.4.
that gives us about 43,
43.6.
43.6%. 679 out of 1204 gives us,
54.
I got 56.4.
Yeah, oh, I messed up.
I have 54.4 in my notes, but that's obviously wrong because they must add to 100. Yeah,
I just
Yeah,
do the
56.4.
2 after the decimal.
that's fine. I'm not, yeah, I think I specified on the test. I'm pretty sure I did. Then you do 321 out of 598. I have 3.7. Don't forget that you have to round up sometimes, right? And then 277 out of is 46.3.
And then for C, do you want us to find the chi-square?
One more thing, okay? So this tells us the percent of yeses, does that make sense? Who were male versus female? And the percent of the no's who were male versus female. Which one do you think is more worthwhile? The first one. And the reason I would say that is that what if you had like a huge sample size of women, like twice as many women as men? that would skew these row percentages, these column percentages a lot, right? So that's what part C is kind of getting at, and you don't have to do a chi-square thing yet, okay, because I didn't ask for it. So it's just trying to get you to see that you should look at the row percentage. What is the approximate difference between the genders? So women use social media.
Close to 10%.
About 10% more. And this is probably a relationship, as this is probably a difference. I'll probably just ask you to straight up find a chi-square thing, like as to verify that that actually is true. Is that all right?
Probably a relationship?
Yeah, probably a difference between the groups, we'll say,
Okay, that, yeah.
between men and women. Or you could say there is a relationship. That's fine too. It's the hard thing with grading stats. After you read what you write. Not saying it's bad. Just saying I can't just look at numbers. Is that part okay? All right. So did I fix yours to say the right thing? No. Nope, okay, deducted on. I must have copied, pasted, and booed, okay. Those, yeah, smoking people. So the risk of being divorced if you are a smoker and if you are not a smoker. So, risk for being a smoker. Smoke, I can't spell either. So how many, so this is the number of smokers divorced divided by the total number of smokers. So how many smokers had been divorced? Out of, and that should give you 0.491. Risk for non-smoker. So how many non-smokers divorced? Number non-smoke divorced is 374. Number non-smoke is 1184. And what that is saying is that almost half of smokers get divorced versus 31% of non-smokers, right? Does that make sense? Okay, so those are the risks for those groups. How about the relative risk of being divorced for non-smokers versus smokers? So that's the risk for the smoker divided by what? Risk for the non. So the risk for the smoker was 0.491, right? The non-smoker was yep, so I got 1.554. So you say your risk of divorce is 1.554 times higher if you're a smoker versus non-smoker. That's where that kind of thing comes up.
This can be in percentages too, right? This can be in percentages too.
That one really can't be in percentage. Well, you can, that's what the next thing does. It makes it into a percent, kind of. The percent increase in risk, I'm so sorry. Not being bullied. Same thing, risk of smoke compared to not. What was that formula? Look at that, without a note card. Times 100%, right?
Yep.
The stuff you memorize without wanting to. 1.554 minus 1 times 100% is a what percent increase? Mm-hmm.
55.4.
Mm-hmm. Okay. We'll probably get through this one, but not the last one. Happens. Okay. So when you're looking at p-values and chi-squared values, you reject h naught if p is what?
Less
Less
than
than
0.05.
Yep. And you reject h naught if chi-squared is,
Greater than 4.84.
I will never give you a number that's exactly 0.05 and exactly 3.84 because what's in the boundary is a little bit like ambiguous, okay? So this means there is statistical significance. A lot of you were confusing that. Like you were confusing statistical significance as thinking statistical significance was not rejecting H naught. If you reject H naught, there is statistical significance. Don't reject H naught, there is not statistical significance. So with p-value 0.055, can you reject H naught? No. Is that smaller than 0.05? No. So no reject H naught. It's not statistically significant. Is it close?
Sure.
Yes. Yes.
I thought you said the rate failed to reject H naught, and then we said don't.
Don't reject H naught is fine. Fail to reject H naught is fine. It doesn't matter. Just don't reject H naught. Okay, how about chi-squared is 2.38? Yep. You cannot reject H naught. Is it statistically significant? Cannot reject H naught. Not statistically significant again. If your chi-squared is 4, yes, then you can reject H naught. Is statistically significant. Okay. So let's actually go back to that smoking divorce thing and figure, is that approximately 10% difference actually significant or not, okay? So H naught, your null hypothesis is that there's always no relationship. So there is no relationship between what and what?
Smoking and the abortion.
Mm-hmm. Smoking and divorce rate. HA, the alternative is that there is a relationship. Okay. Expected values. What's the formula that you use to find these?
Is it
Row total
column total
times column total
by
divided by total total. Yep. I'll just tell you what they are. So you have the yes, yes, no, no. The first one's 177.84. The second is 307.16. This one is 434.16. And the last one is 749.84. On my notes that are online, I have the work written down as well if you want to see it, okay? Like I put down what numbers I multiplied to get them. And remember these, you have to always have 2 decimals of accuracy. Don't round, okay? Oh, round, but 2 places, okay? And the last thing we'll do is we'll finish this one question. Chi-squared, how do you find that? You do a sum of observed minus expected squared over expected. So in this case, that's, the observed was, for yes is 238 minus 177.84 squared over 177.84. Plus, what's next? Minus
7.6,
over,
307.
great. Plus 374 minus 434.16 squared over,
434.16.
and then plus
810 minus 749.84 squared divided by 749.84.
okay. And I made a boo-boo in my notes and I put a wrong number in. You're gonna get a big chi-square, but I don't